Okay, let's go ahead and look at some properties for logarithms like we've done with all of our other functions. So if we have y equals log base a of x, that means the same thing as x equals a to the y. Remember, it means y is equal to the exponent you put on the base a, to get x. Okay, so remember, y is always an exponent. It's easy to lose sight of that, but if you think of them like exponents, it helps you get in the right frame of reference. Okay, so all of our properties of logarithms. So here's the one we just saw. We're talking about bases that are greater than 1. Okay, these are continuous functions. They're 1 to 1, and we already know what their inverse is. Their inverse is the exponential function with the same base, and they're increasing functions. Their domain is from 0 to infinity, and their range is from negative infinity to infinity. Now remember, since they're the inverse of exponential functions, these domain and range were switched. So reminder here that this domain means that you can only plug in numbers bigger than 0. It does have a vertical asymptote at the the y-axis. That would be x equals 0. Okay, and because of that, it doesn't have a y-intercept because you can't plug in 0. Okay, so let's use the definitions of logarithms to figure these out. So first we want to find out, what is log base 10 of 100,000? Well, remember, we're saying what exponent do we put on 10 to get 100,000? Okay, and if you need to kind of use your calculator to help you out, remember I showed you that we could put in our y equals 10 to the x, and then just kind of look at our table and see, okay, for what x value do we get 100,000? And that would be for 5 here. So this would be 5. Okay, now we want log base 8 of 1. So that means, what exponent do we put on 8 to get 1? Well, what exponent do we put on anything to get 1? It would be 0. Log base 7 of 7, there we're saying, what exponent do we put on 7 to get out 7? Well, that would just be 7 to the first power, so y would be 1 here. And then this one, we want we have log base 16 equals 4. So that means, log of 16 of 4. So we want to know, what exponent do we put on 16 to get 4? Now notice 4 is the square root of 16. So how do we write the square root of 16 as an exponent? Well, that's the same as 16 to the 1/2 power. So our log base 16 of 4 is 1/2. Okay, now we're going to look at these and say, okay, why is this true for any base a? If we had log base a of 1, why is that always 0? Well, log base a of 1 means, what exponent do I put on a to get 1? And like we talked about above for 8, it would be 0, because any value to the 0th power is 1. Okay, and then log base a of that same number, so here we're doing log base a and we're plugging in a. Well, why does that equal 1? We're saying, well, a to what power equals a? And obviously it's 1. So here we can say any value to the first power is itself. Okay, so it's just some more basic properties of logarithms that you should know.